Hey grade 8s, welcome to your Wednesday math. I hope you guys have been enjoying the very nice extraordinary heat. It's crazy to think that at the beginning of this month we had snow and now we have a heat warning in about 2 weeks. Doesn't make any sense, but here we are. So today we are doing a little bit of a review from our Monday as usual, and then so we talked about how to take a number and to expand it into notation. Today we're taking an expanded number from notation and putting it into its regular form. So today, let's start with our review. So we have 1,358. If I am breaking this down, I will go 1,000 plus 300 plus 50 plus 8. How can I put this in expanded notation? Well, I know 1,000 is 1 times 10 to the power of 3. And how I know that there's 3 is because there's 3 zeros after that 1. The number of zeros is the number of places, so thousands, hundreds, and what have you. So plus, remember to always do a plus in between your different sections. 3. And then we do times 10, and now we have to figure out what the power is. And for hundreds, we know it's to the power of 2 because 10 times 10 is 100. Plus 5 times 10, and this time it'll be to the power of 1. So that's basically just 10 times 1, or just 10 by itself. And then plus 1 times 8, because we have to do the full notation. So I saw some of you guys just did plus 8 or plus 7. It's still technically correct, but if you're doing the full proper notation, you would actually do 1 times 8, or 1 times whatever number. And same with for your tens column, you would do it by 10 to the power of 1. So that is for 1,358. Now let's do 5,637. So it is 5,000 plus 600 plus 30 plus 7, which equals 5 times 10. And we know for 1,000 it's to the power of 3, plus 6 times 10 to the power of 2, because we know the hundreds is 10 to the power of 2, plus 3 times 10 to the power of 1, plus 1 times 7. All right, and there we have it. So today's lesson is probably, for some of you, might actually just be easier than the last one, is we are taking our expanded form and putting it into a regular number. So for our first problem, we have 4 times 10 to the power of 3. So remember BEDMAS, we have to do our exponents first. So I do 4 times, what's 10 to the power of 3? That's 10 times 10 times 10. 10 times 10 is 100, times 10 is 1,000. So that's 4 times 1,000 plus 3 times 10 to the power of 2. 10 times 10 is 100, plus 7 times 10 to the power of 1. So 10 to the power of 1 is just 10, plus 1 times 9. All right, and now our next step is 4 times 1,000 is 4,000, plus 3 times 100 is 300. 7 times 10 is 70, plus 1 times 9 is 9, equals, I'm just going to put it over here because I'm lacking in space, is 4,000 plus 300 is 4,300, plus 70 plus 9 is 4,379. So 4,379. And that's my number there. What about this number here? Well, this case is a little bit different because, as you can see, we have 10 to the power of 4. So what this means, instead of 1,000, we have 7 times 10 to the power of 4 is 10,000. So we're going up. 10,000. So as you can see, there's 1, 2, 3, 4 zeros. That's how you know. It's a nice little trick to figure out what your powered numbers are. So 7 times 10,000 plus 9 times, and we know 10 to the power of 3 is 1,000 because it's 10 times 10 times 10. So plus 9 times 1,000 plus 6 times, we know 10 to the power of 2 is 100 because it's 10 times 10, plus 2 times 10 because 10 to the power of 1 is just 10, plus 1 times 1. Oh, this is freaking out. All right, so again, 7 times 10,000 is 70,000. So sometimes you can even just put a comma there if it helps you out. Plus 9,000 plus 600 plus 20 plus 1, because we did 9 times 1,000 is 9,000, 6 times 100 is 600, 10 times, or 2 times 10 is 20, and 1 times 1 is 1. All right, and now we add this all up together. So 70 plus 9,000 is 79,000 plus 600 plus 20 plus 1. So if we're just doing this all up together, we look at our first placeholder, so 7, then 9, then 6, then 2, and then 1. So I have 79,621. So that's that. We're also going to do a couple questions that go all the way up to 1 million. So 1 million. $1 million is equal to 10, and we have to figure out what the power is. How we figure out the power, you can use just the zero trick by counting the number of zeros. So 1, 2, 3, 4, 5, 6. There's 6 decimal places, or there's 6 places after that 1. So it's 10 to the power of 6. 100,000 is 10 to the power of 5, and we already know that 10,000 is 10 to the power of 4. 1,000 is 10 to the power of 3. 100, 10 to the power of 2. And the tens column is 10 to the power of 1. And there we go. So we're actually going to be doing up to 1 million places, or up to exponents up to 1 million. So let's do another number that we have expanded notation we need to put into regular form. This time it's going to be a little trickier because we're going to have the million places, but we're also going to have, so 7 times 10 to the power of 6 plus 8 times 10 to the power of 4 plus 6 times 10 to the power of 2 plus 1 times 6. All right, so we need to figure this one out. So I usually like breaking it down into sections. So 7 times 10 to the power of 6, as we now know, 10 to the power of 6 is equal to 1 million. So 7 times 1 million, so it's 1 with 6 zeros after it. I usually just put commas to help visualize it and just see it a little bit better. Plus 8 times 10 to the power of 4. 10 to the power of 4 we know is 10,000, so that's going to be 8 times 10,000. Plus 6 times 10 to the power of 2, we know that 10 to the power of 2 is 100. Plus 1 times 6, which is 6. I'm just going to add that on to the end. Now we have 7 times 1 million is 7 million. So we have 7 and then 6 zeros after it. Plus 8 times 10,000 is 80,000. Plus 6 times 10, which is 60, plus 6. All right, so now we have to put these numbers in the right decimal spaces, because as you can see, I didn't go 6, 5, 4, 3, 2, 1 for the exponents. We just went, there's going to be some zeros in some certain places. So now we have 7 million, which is, we know that 7 is going to be at the beginning. We don't have anything for 10,000, because right here is our 10,000 spot. We don't have anything, so that remains a 0. This is our 10,000s place, and we do have something for the 10,000s, so we go 8. Now our thousands place, we don't have anything in the thousands, so that remains a 0. Now we have our hundreds. We don't have anything for hundreds, so that remains 0. Or sorry, we do have something for hundreds. I forgot. That was supposed to be there. My mistake. So we have 600. That was supposed to be 600, not 60. My apologies. So that is our 6. We don't have, we don't have anything for our tens spot, so that is a 0. And we do have something for our ones column, which is 6. So we have 7,080,606. And that is our final answer. So usually when looking at problems like this, I usually will just break it down like how I've done here. Is we do our first section, which is right here. The second section, which is right here. Third, which we ended up doing right here. And our last ones column, which is right there. All right, so today you're going to actually have questions with exponents like this that you're putting into regular form that are going to be up to 1 million. There's going to be a couple in the thousands, a couple in the 10,000s. It's going to be kind of all over the place. The smallest you should probably have is 1,000. So it's going to be between 1,000 and 1 million. So remember that you will not be dealing with anything higher than 10 to the power of 6. And your lowest is going to be 10 to the power of 3. Or for your first decimal place, as in your first place of the number. You can be going all the way down to the ones for the entire answer. So there you have it. So that's what you guys are going to be doing today. It's going to be an expanded notation. You're basically just going to be writing in the final answer, the final number for it. Let me know if you guys have any questions whatsoever. Be sure to enjoy some of this nice weather and get some fresh air and everything. And I will see you guys on Friday. And I hope you guys are having an awesome week.